I spent almost 50 years in professional life, and all of them devoted to various aspects of audio-visual communication systems. Sometimes coding, sometimes network, sometimes human factors. And out of those 50 years, more than half, 28 years in international standardization. So probably I'm a little bit qualified to talk about history. And okay, so first I will touch upon brief overview of video coding technologies and also video coding standardization. Next, I'll talk about H.261 development, how we reached the consensus building. That's I think a principal contribution to the 6th or 7th generation video coding standards, and I'll also talk about the comparison of H.261 and the most recent H.265 HEVC standards. And finally, I'll talk about about standardization. There are merits and also demerits. And also, my final topic is challenge to the video coding standardization. So first, this diagram shows the progress of video coding technologies, how I see it. And we have three lines. One is PAL-based coding. The second line is block-based coding. And the third line shows the variable length coding. And in the PAL-based coding, we started with PCM, just digitizing the analog video. That is the 1950s achievement. Then there is a great step, even if it's very simple, but a great step, DPCM. That is the 1960s development. And the next one is simple interframe prediction. That is just an extension from PAL by PAL difference to the difference between the two frames, but use of frame memory, that's very expensive at that time. So really, in 1970s, the idea is simple, but it was achieved in 1970s, simple interframe prediction. Then comes a very big jump. That is the motion compensated interframe prediction. That happened early 1980s. That's the line of PAL-based coding. And then the second line, block-based coding. I think two technologies are there: transform, DCT, and vector quantization. Those are dealing with not a single PAL, but a block of PALs. And that was started to utilized early 1980s. And on the right-hand side, you see VLC. And the Huffman coding idea was early in 1950s. And arithmetic code appeared early 1980s. So all of them come together late 1980s, hybrid coding. And the hybrid means hybrid between PAL-based coding and block-based coding. And the VLC is always together. So I think hybrid coding is the framework established late 1980s for the H.261 standard at the first time. Then subsequent video coding standards use hybrid coding, and I don't see any further quantum leap beyond hybrid coding at the moment. There may come in time, but I don't know at the moment. Next slide shows history of video coding standardization. So it started with 1982 BT601 ITOR standard recommendation. So on the left-hand side, you see ITOR, and ITOR address the original PCM signal. So that's the picture format issue. And the BT601, it's SDTV, 709 HDTV, and 1769, that's the UHD-TV, 4K, 8K. And the more details are in BT 2020. And the second line shows ITUT standards. It started with H.120 before H.261. And following that, we have, several generations, 262, 3, 4, 5. And on the right-hand side, you see ISO-IEC MPEG standard. It started with MPEG 1 in 1993, and so on, MPEG 2, 4, and AVC, and finally HEVC. So in this diagram, you see, 30 years history of video coding standardization. And the yellow mark shows the time when I was involved in the standardization. So H.120 and 261 and H.262 MPEG-2 video. Those are the standards for which I worked. And the blue ones, it's rather difficult to identify. Blue character shows the common or joint standards between ITUT and ISO-IEC. Okay, so the really first generation standard, video coding standard is H.120, but it was a kind of non-proliferation policy standard. So unfortunately, we couldn't have a unified standard, but very limited number of standards. That is the policy to reach the standard H.120. So we learned very much from this original H.120 standards and coming to the really world unique H.261. Okay, next slide shows guiding principles of the specialist group to develop H.261. At the time, the group called specialist group. The first guiding principle was the the specialist group should collaborate as closely as possible in defining a worldwide standard for second generation codecs. In this sense, the first generation is H.120, and the second generation means that we don't care about the backward compatibility with the first generation. H.261 should be independent of the first generation. That's the guiding principle. And the second point is the best way to achieve this is eventually by conducting hardware-related project involving international transmission tests. So this is coming from the European experience in H.120. European countries collaborated to work out H.120, and the US and Japan were outside of that activities. So really, the H.261 should be the collaboration among all countries. That's the first one. The second one is hardware. So at that time, we are relying on hardware. And also this international transmission test, this is also coming from H.120 or COS211 project. And in the sense that, this is dealing with what IMTC interop should do. So we really conducted this transmission tests among different countries. And the third point is the aim will be to jointly formulate a specification by means of largely independent but parallel hardware experiments in participating countries. So again, hardware appears. The late 1980s, that is the era when, hardware is the major thing. The final point is very interesting. The group will aim to avoid competition on standards, but at a later date, competition on codec manufacture can be encouraged. So I think this principle still applies to every standardization. Okay, that's the guiding principle, and what we achieved through the H.261 development is this, reference model methodology for consensus building. So at the start, we identified collaboration is what we need, but how can we collaborate? That's we didn't have any idea at the start, but through having meetings and discussions, we reached this methodology. That is we built the first coding model with the element that everybody can agree. So it may be rough, but it is a starting point. And it becomes a yardstick. And then someone may think about adding a new element to this model. That is the left one, red element. Then they will claim that some improvements are obtained compared to the yardstick original model, in this case, RM reference model 1. And the other person may propose to replace the existing elements with a new one, the blue element. And those are agreed. Then we have a next model, next generation, next model, reference model 2. So by doing this iteration, we reach the final recommendation, our standard. So this methodology for consensus building is a very good, I think, achievement through H.261 activities, and the evidence is here. This methodology was employed in various standardization, video coding, or even audio coding. So you see we use the reference model, so RM. And the MPEG one uses the simulation model, SM, and then H.262 MPEG-2 video, you use test model. You see RST. So next one should be UM, but there was no UM. But VM is later verification model MPEG 4.2. So in any case, even what H.265 uses this methodology and use what they call HEVC test model. So the only exception for this standardization, you see MPEG to AAC, they use the reference model methodology. That's interesting. So this slide shows the comparison of H.261 and H.265 HEVC. So date and period, you see 5 years, 3 years, well, comparable. Meetings, number of meetings, 18 and 12, this is also comparable. But participants per meeting, that is 30 against 240. And contributions in total, H.261 case, less than 600. But H.265 HEVC case, more than 6,000. And the number of pages, H.261, 24, and HEVC case, 300. So, well, my observation is here is that the H.265 required 10 times human effort than H.261. And once I calculated how much money we spent for this H.261 project, and I counted human cost, of course. Then I counted $1 US million per page. So that's the project cost. And perhaps the per page cost is the same for H.265. So I think $300 million project, US dollar project. That's the H.265 HEVC. Because I was involved long years for standardization, I should mention about merits and demerits of standardization. Of course, the merits are over there. Mass production can be possible. More than that, interworking, compatibility. That is the first thing I should mention. And also non-tariff barrier. But the demerit is technology is fixed at the time of standardization. So a typical example is here, digital TV broadcasting. Japan terrestrial digital broadcasting adopted MPEG-2 video coding. It was the late 1990s. Currently, 4 times higher efficiency, H.265. HEVC is available, but we cannot replace. So this is a great challenge, great issue. And finally, challenge to the video coding standardization. So my problem is how can we enjoy new evolving technologies by achieving standardization and backward compatibility at the same time. So some solutions are listed here, partial solutions, specifying only the decoder to allow freedom of the encoder design. This is the spirit of the current video coding standardization, I think. And the use of negotiation if a bidirectional control channel is available. Well, in the communication area, we can use the H.245 or SDP message exchange to identify a common common element we can utilize. But one-directional system, it's not possible. And finally, software replacement in case of software codec. I think this might be the solution. And the web browsers are updated every 6 weeks. So by using the same type of method, we can, well, solve the problem of utilizing new technologies and also achieve standardization. Well, that's conclude my presentation. Thank you.